This is a really, I think, a very important topic for all of us to consider, which is how the genetic variants are going to potentially affect the transmissibility of SARS-CoV-2. Eric Poeschla, who's head of the Division of Infectious Diseases, is going to be helping us think through this problem. And I think Eric has a number of slides that he wants to present, and then we'll open it up to discussion. But as usual, put your questions in the chat box. I'll keep track of them, but also feel very comfortable unmuting yourself and asking a question. So Eric, why don't you go ahead and start? And thanks again for taking the time to pull this presentation together.
Sure, thanks, David. So I've divided this talk into three parts. First, I'll talk about the variants and what they are. Then I'll go into sort of competing theories about what's going on that involve founder effects versus the more transmissible hypothesis, which most people are moving towards now. And then I'll talk about implications for our epidemic and for immunity and vaccines. So this is a sentence I wrote in December in a commentary that the journal eLife asked me to write on a paper describing how you can induce SARS-CoV-2 to escape from neutralizing antibodies. And I was referring here narrowly to an experiment, to a particular set of striking experiments that have implications for what is going on now. But the story I'm about to try to convey is about natural selection and evolution on a global scale. And so, of course, that brings up not pleasure, but a more range of things. And emotions, and namely concern about what may happen. So this is a really an amazing story. It's fascinating, it's unfolding fast, and whatever the real risk, not entirely clear yet, this is going to bear close attention by all of us. All right, so this is what I woke up to this morning on my iPhone. Distracted by the DC political crisis, the US sets daily records for deaths. There were 4,610 deaths yesterday in the US. And these are the hospitalizations for both the USA and for Colorado. And you can see that the USA continues to decline steeply. And we might be lulled a little bit by the distraction from all the mayhem in Washington, as well as by the fact that our hospitalizations are falling here in Colorado since December 4th. And so I think it's a good time to sort of look ahead and see what might be coming. So I'm going to be talking mainly about the spike protein, which is on the surface of the virion, binds to the ACE2 receptor and mediates entry of the virus. And a number of mutations, in particular tyrosine 501, lysine 44, you'll hear me mention. And this is all in a spike protein on the surface, which sort of waves around here on the surface, and then latches on to ACE2 and mediates entry. To set the scene now, this was London on December 5th, 2020, in downtown London, just outside Harrods department store. Young people were protesting closing of bars and nightclubs and shops. And as you can see, this is a perfect super spreader event. There's not a mask in sight, people are bunched together. And this is not to criticize our English friends, because of course we had a major super spreader event in our capital just a week ago. But this is the kind of thing that's going on around the world and is not helpful. Okay, so there are currently two main variants of concern, or VOCs, and the first one was identified in Britain, the other one in South Africa. Each is acquired over 20 amino acid substitutions, which is relatively a lot. And the first main lineage I'll talk about is called B117. It's also known as a UK variant, or 501YV1. It was first flagged to attention in England in early December 2020 by combining viral genome data with knowledge that rates of infection in Kent in the southeast of England, were not falling, despite national restrictions. There's a main amino acid change in spike N501Y. I'll talk more about that. There's also 8 other total amino acid changes in the spike and about 23 total in the virus, including a deletion in spike that shows up fortuitously in some diagnostic PCR tests. And that's called a spike gene target failure, which is how they've been tracking it and how it'll be picked up in the US. It also has the disruption of a gene or fate. There's no evidence that any of these, or this one, caused more severe disease. It was first detected in the US in Colorado on December 29th. There's been 4 more since, one over at the Veterans Home at Anschutz, actually right across from the gym on our campus. 9 states have now reported 72 total cases as of January 13th. But that's really beside the point, because the virus is here. It's probably here much more than we know about because US surveillance is pretty poor overall. I was talking to Laura Bankers, who was a postdoc till recently in my lab, is now a bioinformatician at CDPHE. And this is the information she was able to give me tonight. I don't know if she's on or if she has anything more to add. Laura, are you there?
Yeah, I am on.
Anything more to add to that?
No, I mean, the original first 2 were both National Guard that were working at a long-term care facility. Other 2 were from the VA, and then the 5th that we have confirmed is from a commercial lab, but we don't know much about this person yet.
Okay.
Laura, Laura, this is David Schwartz. I just had a quick question for you. How are you screening for these variants? In other words, of all the viruses of all the PCRs that are done, how do you decide which ones you're going to screen for?
So right now we are sequencing all S gene target failures that we can get. Anything that has a CT below 30. Any higher than that, they really don't sequence well. And then CDPHE also is doing a bunch of surveillance sequencing. So we have more than 17 different sites across the state that are sending us 5 random samples a week to sequence.
Okay, so this variant might, and I emphasize might, have arisen by prolonged replication in an immunocompromised person, and I'll come back to that. And the second main variant of concern is called B1351, or also the 501YB.2 lineage. This is also known as the South African variant, and we don't in general want to call these by their countries because we actually don't know where they arose, but that's where they're first identified. It was first detected in South Africa a little later on 18 December. And like B117 in the UK, it rapidly displaced other lineages in South Africa. And there's much less data for this, but it's a little more of concern actually because it has the N501Y mutation up near where there's binding to the ACE2 receptor, but also has 2 others, in particular E484K and K417N. And this glutamate to lysine is a sort of major shift. It goes from a negatively charged acidic residue to a positively charged basic residue, kind of like if you had 2 bar magnets stuck together and turn one of them around, and now they're pushing against each other. So this also turns out to reduce some neutralizing antibody binding too, which concerns people. There are additional variants coming up of concern that are less is known about or being talked about. There's B1128. This is now named the P1 lineage in Brazil. Amazonia is actually fascinating now. It's being devastated by COVID. There's up to a 70% prevalence, among the highest in the world, hurting a lot of people. And because of that, there may actually be high immune pressure there now. And so similar to B1351 in South Africa, it's thought this lineage arose independently that also has these 2 amino acid mutations. And the hypothesis is that this is convergent evolution for some advantage of that combination, perhaps partial neutralizing antibody deflection. And then there's some others you've heard about. D614G is dominant everywhere now. I won't go into that. Cluster 5 on the Danish mink farms led to a massive cull of 17 million mink there. There's a hypothesized threat of parallel sort of reciprocal human-animal exchange of those viruses. And then most recently, people have talked about a USA variant, but that really doesn't have significant yet. It's just that it does create a target gene dropout, S gene dropout in PCR. Where are these? I've shown you this. This is a modeling of actually the South African variant. They're in the spike protein. Here's that deletion, a histidine valine at 69 to 70. Here's the main amino acid change that people have been talking about, and then E484K. There's also a proline to histidine at 681 that affects the furin cleavage site, which might affect infectivity. There's really no evidence on that yet. And I won't go too far into the weeds. Laura just talked about this. That's 2 amino acids, so it's 6 nucleotides. That blocks binding of the probe once the amplicon for spike and PCR tests, and some of them, like the TAC path, which is used in England, and also at CDPHE. And so you can now identify this from standard diagnostic PCR. It doesn't take sequencing. It does take sequencing to confirm it, because maybe half of actual SGTF samples are actually this variant. And then the CDPHE lab saw it first. Just talked to Adriana Weinberg Monday, and they're not seeing it yet. Laura confirms that in UCH, but they do run TAC paths, so they have the capability to see it. Now, this is possibly contributing to transmissibility. Now, this is experiments done in vitro of proteins. And this is looking at a shift to the left. In other words, at a given ACE2 concentration, how much binding do you get of the spike? And with just 501Y, you get a shift. With both of these two together, 501Y and 484K, you get a major shift to the left. So now this is binding more tightly. The KD is much lower to the ACE2 receptor. There's other theories that it might create higher viral loads as to why it's transmissible. If I have time, I can go into that in the end. So what's happening epidemiologically? And this has been described as going vertical. You can see that this is total cases, not just this variant. The UK just took off in early December. It's going through the roof. Ireland is just amazing. Right in sort of mid-December, it just took off. These are cases per million, really just meteoric rise. And if you look at the percent of total UK sequences by this variant, it's not just spreading very fast, but it's replacing other strains. It's displacing them. Late December, end of the year, it was up to 70%. And in Ireland now, that variant is 43% of Irish cases, and it was only 8.6% on December 20th. So this thing is displacing, and I'm going to show you a movie now that is quite striking. I assume you can see a map of England now?
Yep. Yeah.
Okay, so this starts on November 10th, and it goes up to December 29th, so 49 days. And what you're looking at is the proportion of spike gene target values, the number of tests that turn out to be positive. So the deep indigo is basically 100%. This isn't numbers, this is percent. You can see as November goes on, everything becomes blue, starting in London. Here's London up here, and then spreading throughout the rest of the country. And it gets up to basically almost 95% now in England, especially in the southeast. Quite striking, quite rapid, became completely dominant. And then just to put this in perspective, this is just one of many, many variants. Here's B117. There are hundreds of these. I'm just scrolling down through the list. Hundreds and hundreds. I'm not even halfway through the scroll here. Okay, so let's put this in the context of the US. We're also climbing a kind of slow grind upwards because of all sorts of reasons. But we haven't taken off just this much. But if we do have a B117 effect, it's going to start higher. It's going to start here as opposed to down here for Ireland. So the lesson for us in Colorado is that we're in this current relative low. Cases have been falling, but it could turn on a dime. This is a good point as any to introduce, for those of you who want to delve into the phylogeny more, this is a good time to introduce a remarkable young woman scientist, Emma Hodcroft. She's a computational biologist, and she started what's called the NextStrain platform, where you can track these things. She's actually an American from Texas. She's now in Switzerland. She calls herself Die Virenjägerin, which in German means the virus hunter. And she, with another person, created this website. Here she is on her Twitter page, shooting a phylogenetic arrow at the virus. And this is what you get. So this is over time, looking at all the clades. Here's B117. These are, each dot here is a sequence. And there's the South African one. And they came up over time, and you can see them starting to appear in the fall. Actually, look back in England detects B117 around September. And then they're accumulating in number too. That's a little bit artificial because we're disproportionately sequencing those in England. England has by far the best sequencing operation of all. Does my Zoom thing block the headline here?
No, not at
Oh,
all.
okay.
Now, Eric, when you say they have the best sequencing operation of all, what proportion of viruses are they sequencing?
They're sequencing about 10%. We're sequencing less than 1%. And they're the best in the world at that. They have an amazing sequencing operation. It's really remarkable. So they're sequencing about 10% now. So if you zero in on the two variants, here's B117, here's the South African variant. You can see this come up in September. You can see this is the circle indicating dominance. You can see it's starting to pop up in other places. That South African variant is coming up in South Africa. And now this is a different view you can get on this page, looking at the clock of nucleotide substitutions. And so over time, from February to January, the number of mutations increases as expected, with a expected rate estimate of about 22 substitutions per year. But you can see that B117 is high, up in the 30-ish range. This variant, a little bit high. And if you compare these two numbers, you can see that we go from 22.5 substitutions per year to a rate estimate of 30 substitutions per year. Now, what that does not mean is that the virus, and generically the virus, is now mutating faster around the world. What that means is that you look at these variants, this is the number calculation for their past here in the last year, more substitutions. Okay.
Eric?
Yeah.
This is Ed Janoff. So are these mutations all in the spike protein, or are they preferentially in the spike protein, or do you find them in other parts of the virus?
There's about 8 in the spike protein in B117. There's about 15 others elsewhere in the virus. But the ones that are concerning for transmission, and it hasn't been experimentally tested that other mutations might not affect the virus, but everyone's sort of focused on spike now, and there's experimental evidence that that may increase transmissibility. But we're really talking about the spike protein.
Right, but I was thinking about selection pressure, and is it
just
focused primarily on the spike?
Exactly. So the great debate here that's been going on for the past month and a half is, are these what are called founder effects, chance effects, or does this reflect actual greater transmissibility of a single variant? And the opinion now is really moving towards greater transmissibility. And so is it a founder effect? All viruses mutate. This virus has been mutating as expected since it emerged, all evolved, that's axiomatic. So mutants per se does not mean scary. Coronaviruses also proofread as they copy, so they generally have a somewhat lower per cycle mutation rate. And so without geographical homogeneity in two things, behavior like masking or variant distribution, you're inevitably going to have some spread more rapidly. And in the initial, a lot of people said this is just a founder effect. Don't jump to conclusions. This reminds me to give an analogy. If a boat with 3 red-haired people and 1 brown-haired person gets shipwrecked on a South Pacific island, which actually sounds rather nice right now, inevitably, when they start reproducing, you're going to have a lot of red-haired people. That doesn't mean red-haired people are more fit or they're better at reproducing. It just means that they happen to be there and exploit the niche. And now in this section of the talk, this may be the most important slide I'm going to show you because as I showed you, there's much circumstantial epidemiology now that this virus transmits better. But just on January 8th, less than a week ago, really important new data came. And this is actually also remarkable and part of the much better UK sequencing operation. This is on secondary attack rates, in other words, contact tracing, called Test and Trace program. They did contact tracing of almost 1 million people. Very impressive. And so this is the B117 variant. This is wild type, almost 1 million people. To cut to the chase, the contacts of these people who became cases was about 15%, of wild type about 11%. So 15% versus 11%. And that may not seem like a big deal. So you said, okay, 15, 11, but I'll show you why it is a big deal. And this is secure. There's a lot of numbers. I'm not showing here the second part of this table. It was the same across all age groups. And they stratified it into 2 levels of contact, direct and close, and it was the same there. It was a pretty hard finding, and I think this is considered now the smoking gun for most people, these data. So the current thinking is not universal, but this is the growing consensus among experts, is that it has a substantial transmission advantage. The virus in South Africa may also too. It also rapidly replaced others. That the reproduction number, or R naught, may have increased about 0.4 to 0.7, with the ratios between that and the wild type about 1.4 and 1.8. So about, quote, roughly 30 to 50% more infectious. It's not, as you saw, this is really spreading in a mostly non-immune population, pre-vaccine. And so it's not likely the result of natural or vaccine immune pressure or immune selection pressure. In fact, it may have actually arisen in an immunocompromised patient where there wasn't immune selection pressure. So to get back to Ed's question, perhaps not immune pressure at all yet, but that's a future thing we have to look at. And so the number of non-synonymous changes is a lot, and it suggests that there's been an extended period of within-host evolution, within one-host evolution. There's actually case report evidence that I'll get to about rapid evolution in single immunocompromised patients now. Christian Andersen, who you may possibly remember, published the proximal origin of SARS-CoV-2 paper in Nature Medicine in the spring. Very good phylogenomicist, and he just said the other day, if we continue down our current path of American inaction and wait to act until B117 is dominant, it will be much too late. Don't think it can get worse, any worse, wrong. We need additional measures in place now, better masks, universal testing, additional social distancing. So why is there still a debate, founder effect versus more transmissible? Well, first of all, this is almost all observational epidemiologic and phylogenetic data so far, although as I just told you, the contact tracing data now are fairly convincing. And so, but you could call this circumstantial retrospective, not well controlled for confounders because it's population-wide, certain forms of bias. And there's almost no experimental virology that's been done. There's a few things posted on the web that really aren't convincing. But this is what has to be done over here. You got to engineer the specific mutations into the virus and test those side by side for per particle infectivity in the lab. That has to be done right. It's not simple. And even that's not necessarily convincing. If I show you that B117 is more infectious in ACE2 expressing A549 cells, that's not a person. Animal experiments also have to be done. And this is all going to be done. There's an avalanche of people working on this. And probably in hamsters and ferrets, but again, weasels aren't ferrets either. So you have to do these kind of experiments with direct contacts versus indirect contacts between cages. So that will really nail it. But I think most people think that it's going to show it's more transmissible, but it's still an open question. Now, is this surprising? Well, this is a slide I showed people at Grand Rounds in early April, again using that next strain platform, asking is the virus changing? And I'll just cut down here. This is where we were back in March 31st only. All RNA viruses generate quasi-species or diverse forms. What I said then is true now. At present, there are no data to indicate evolution to greater or lesser virulence, particularly likely. And at the time, what I thought, and I think most people thought, and some people still think, is it's already highly adapted. It's good to go. It's spreading like crazy, using the human respiratory tract as an aerosolization device. And it really doesn't need to evolve to become more infectious. Well, viruses exploit niches and evolve, and they change. And so that was then when I gave that talk, and this is now. In just 1 year, the virus is replicated now through at least 100 million people, 20 million in the US, probably many more than that. It appears to have recently crossed the species barrier from bats, either directly or indirectly to humans. So it's new to humans, it's still adapting, it has much opportunity now. It's still massively replicating in its new host. And going forward, immune pressure may come into significant play. Still, no evidence for change in pathogenicity. And I'll just point out that the evolution of viral pathogenicity is never simple. You hear people say things, well, isn't it true that viruses generally evolve to become less pathogenic as time goes on? And it's all very contingent, depends on the virus, the situation, how it's spreading, how it spreads, whether it's respiratory or not. So there's no rule for that. That's a tricky area. For the last part of the talk, I'm going to talk about implications for the epidemic here and for vaccines and for care of patients. So R0, which you've probably heard a lot about, is the basic reproduction number, or average number of secondary infections an average person generates. It's not a fixed property. The value at any given time, or R time-varying basic reproduction, RT, number RT, depends on 4 components: duration, opportunities, transmissibility, and susceptibility. And the duration of infectiousness is not under our control. The transmissibility, this intrinsic viral property we're talking about, is not under control. But behavior, opportunities for transmission is, and the susceptibility of the population is just now coming under our control with things like vaccines. All right, just to go into the weeds just a little bit, because it's important. Seemingly, you know, I said to you, what's 15% versus 11% secondary contact attack rate? Well, little changes in RT mean a lot. So if RT is about 1.2, one person leads to 3 more cases in a month because it's exponential. And that's what's driving most surges now. If you talk to the epidemiologists, they're saying it's about 1.2, and that's bad. That's what's driving the surge in California. It's not good. Now, if it goes up 50% to 1.8, one person leads to 34 more cases. And other things being equal, immunity, treatment, distancing, masks, being kept equal, a 50% increase in that value without other changes will be catastrophic and would lead to a total loss of control in the United States. So you want RT less than 1, ideally about 0.6, 0.7. There's no political appetite for that in the USA now. All right, so just a question, what would we rather have? Would you rather have a more lethal SARS-CoV-2, 50%, or a 50% more transmissible one? Well, obviously in any one patient, we wouldn't want a 50% more lethal one, but on a population basis, we definitely want a more lethal one. Sounds counterintuitive, but this is work by Adam Kucharski, another brilliant young scientist. He's at the London School, and he models infectious diseases. And you can see here that if you increase deaths, according to that equation I just showed you, by 50%, you get a 50% increase in deaths. Not good, but if you increase transmissibility by 50%, you get a huge increase in deaths because of the exponential effect. So you really would prefer on a population level a 50% more lethal virus than a 50% more transmissible one. But I'll just point out, you don't need a new variant to see all the bad things go exponential. Despite our low in Colorado, all US regions, including the West, are having sharp rises in COVID-19 cases. Arizona has gone through the roof after tamping down from the summer before any transmissible variant effect. So acceleration of the pandemic in the US continues to be a national emergency. It's time to pull out all the stops on masking and distancing and so forth, and vaccine delivery. Now, this is interesting to our clinicians, to you. it's thought that this virus may have arisen in a UK immunocompromised host. That's still a hypothesis. And the case below here, a very well-documented case in the New England Journal of Medicine from Brigham Institute and Harvard Medical School and the Brigham, including Bruce Walker and other people, documented this case. This is a very immunocompromised patient with antiphospholipid syndrome. He got a whole bunch of immunosuppressive agents. And you can see that he's PCR positive at day 150 out here. And it's live virus because the virus is changing. And you can see that here in the RBD and spike, that N501Y came up and fixed. E484K came up and then went away. Out at day 152, this virus was still changing. Now this is not B117, but it's thought that that variant may have come up in a patient like this. This has potential, and I say potential implications for convalescent plasma use. This patient did not get it. But if you think about it, giving large quantities of poorly characterized, often low titer stuff to many people, especially if they're immunocompromised, could have implications. This is theoretical. I'm not saying we shouldn't give convalescent plasma. Full disclosure, I just gave convalescent plasma about a month ago to a severely immunocompromised patient with no B cells and lymphoma. And also those patients are hospitalized and confined. But it's just something we should think about going forward, that you could exert immune selection pressure in the presence of really prolonged replication. All right, big picture, variants are worrisome. Impact is not yet clear in the US, a lot still unknown. We're flying mostly blind. US sequence is less than 1%, as I said before, Britain about 10%. It's in the US, we don't know how much. We know that the doubling times in the UK, Ireland, and now Denmark for about a week. And if that extrapolates to the US, we might expect, rough prediction, can't be sure, that and other things don't happen, like much more vaccine coverage and better non-pharmaceutical interventions. It could become dominant in certain areas like California in late February, early March. So stay tuned on this and other areas. Like I said, we have a lull here. It could turn on a dime. Look at Arizona. Go look at the case and hospitalization numbers for Arizona, how they came down, and they're rocketing right back up. We know how to mitigate. We need to double down. There is a present failure in the US to have a national pandemic strategy, which is what we need. Hopefully, hope is on the way next week. We have poor surveillance overall. CDPHE is obviously going after some of these cases, but as a nation, we're not surveilling enough. We're not doing contact tracing hardly at all at any large scale. We need a vaccination program, not just vaccines, but actually getting needles into deltoids really has to happen. And I really think, my personal view is we need a Manhattan Project. The US military has been proposed for a lot of bad political things this year and wisely said, no way, no how, never. But this would be really something, and this is happening in England and in Israel, the army is administering vaccines. It's the kind of thing that really needs to be ramped up. This is how you take it seriously. Australia has been an amazing, and New Zealand, amazing success case, as have several small Southeast Asian countries. On January 8th, they detected a single case in a cleaner in a quarantine unit, and they shut down the entire city of Brisbane, the third largest city, 2 million people, snap 4-day lockdown. That's politically impossible in the US pretty much, but this is the kind of thing people do. China, different culture, but still takes this very seriously. They just locked down 20 million people. So the last question is, will the variants lead to immune escape or vaccine escape? And I think the overall message here now is cautious reassurance. Unclear, probably not soon. But here's E484, flipping a glutamate to a lysine and flips the charge completely from negative to positive. You can imagine if that a neutralizing antibody is binding up here, blocking ACE2 from binding, that could displace that neutralizing antibody. The paper I was commenting on from the Rockefeller group was fascinating. Each green dot here is a SARS-CoV-2 infected cell, actually a pseudovirus infected cell. They added monoclonal, but also in other cases, plasma, convalescent plasma. And in just 2 passages over a couple of days, you can see resistant virus starting to come up, these little foci. So you can readily select for immune escape from plasma or monoclonals in just 2 or 3 passages over a few days. Now here's a reassuring but very limited result. Convalescent sera still block from actual patients, wild type patients obviously, still block an N501Y mutant virus as well as wild type virus. Here's 501Y, here's wild type in dilution. This is from the Menachery lab, a good lab in Texas, not yet peer reviewed. It's not B117, just N501Y. Mutations at 484, however, in that South African B1351 lineage cause large, greater than 10-fold reductions in neutralization by some convalescent sera, but not others. Here again, N501Y did not, but you can see the real shift here to a much lower serum dilution for both glutamine and lysine replacements of the glutamic acid. Now, let's put this in perspective. Here's subject C and subject I. That was in 2 subjects. If you look at all of them.
You just got a comment from.
What's that? If you look at all the subjects, it was either flat or no effect in various mutations. So, and in this and that prior paper, reduced neutralization occurred in some sera only and did not ablate it even in those. So reduced neutralization does not equal reduced immunity. Here again in that wonderful paper that I was commenting on in my commentary from the Rockefeller group, E484K really had little effect, no effect in this patient. Other mutations did. This is complicated. I have to interpret these preprints. This is actually a published peer-reviewed paper. But what about post-vaccine sera, Pfizer vaccine sera? And so as expected, sera from Pfizer BNT vaccinated people, and there'll be a huge wave of data coming out on this now that people have gotten 2nd doses, neutralize 501 virus as well as they do wild type. Here's wild type 501Y, same neutralization titers pretty much. Caveat again, this is a single amino acid change. The actual UK variant and South African variant have others, and E484K was not tested. But the general principle here is what we're making when we get that mRNA vaccine, we're reacting to the whole entire spike protein. So we're generating a polyclonal response, different, not just antibodies that are at those particular places in the RBD. A monoclonal does bind to one epitope, but we're making many antibodies. And so the take-home message is the vaccines are going to work, and they're probably going to work for the next year at least. There may be time to adapt vaccines. That's a little bit more complicated than people say, because people say, giddy about the mRNA technology. All we have to do is slip in a different mRNA sequence and it'll be really easy. But actually, it's not simple, because keep in mind, the wild type and the mutants will co-circulate. So you probably have to have a mix of mRNAs. So it's not simple to simply plug and play a new sequence, but it can be done. Infectious disease people, my HIV clinicians know this very well. A potential controversial mRNA vaccine is that low levels of neutralizing antibodies from what's being talked about, delaying the booster doses. I personally oppose this, but I can see both sides. After the initial priming doses could lead to suboptimal levels of antibodies. We know from HIV-1 very well that that's exactly where you get resistance. If you have high levels, you don't. If you have no levels, you don't. If you have middling to low levels, that's how you select bioresistance. You could replace drug with antibody here, and it's the same thing. Now, whether that means we shouldn't delay the booster doses, but again, the biggest problem really is getting needles into deltoids. There's a supply problem, but there's a bigger delivery problem. But keep in mind, vaccinations won't have a big impact until many more are vaccinated. This is an example from Israel. Israel has way outperformed every other country in per capita vaccinations. 10 times the US, they've got up to, this is a few days ago, 21% of their population vaccinated. We're down here 10-fold less. And they're still going through their own meteoric rise in the virus right as we speak. So you got to get it up over 70% or so. 21% doesn't cut it. So we have a ways to go. I'll just also point out that it wasn't true that saving the economy, and it isn't true, it was a trade-off of saving lives. If anything, it's the other way around, and the two goals go together. So the countries that kept the health impact low suffered smaller economic consequences. You can clearly show this. This is data from all year now, of January 1st of this year. And I almost, in this, I most likely to compare US and Australia because they're pretty culturally similar countries in many ways, not others. Australia got serious about it. They didn't turn it into a political thing. They shut down the virus. They had lockdowns. They had levels of restriction. And look where they are. They took an economic hit. We took an economic hit. This is the GDP fall. But look at their deaths per 1 million versus ours. All right, just to summarize main points, news variants have arisen, UK, South Africa, and Brazil. B117 is now dominant in the UK completely. It's now also present in the US and in numerous countries. Both are most probably more transmissible, and if true, that's worrisome for reasons I showed. It's a very plausible inference from the phylogenetics and epidemiology. This needs testing by actual virology in cells and in animals. There's no evidence for increased pathogenicity. Some evidence for partial escape from some convalescent sera, especially the South Africa variant so far. No hard data in people. No one's said, okay, this virus escaped in this person. This is looking at sera and their abilities to neutralize. There's no evidence for vaccine escape. The mRNA vaccines are going to work. We may have to, we may see escape in the long term that needs extensive study. We may have to adjust spike mRNA sequences, doable but complicated, as I said. And then I don't want to weigh it. This isn't a talk. I don't have time to weigh on this vaccine dose strategizing question. Low levels of induced antibodies by just priming but not boosting are in principle not a good idea for any of this. Delaying the second dose is controversial. Half dose idea as well. We don't have any data in that. We have no data for any of these vaccines past 21 or 28 days in Pfizer and Moderna respectively, because that's when the second dose is given. Finally, it's replicating massively. It's selecting all over Europe and the Western Hemisphere. East Asian countries in Australia and New Zealand have their acts together. We do not. The US really has to decrease transmission better with non-pharmaceutical interventions like masks, and has to increase the vaccination program. And I can stop there. Oh, stay tuned. It's changing really fast.
Eric, that was absolutely superb. Thank you. I'll start asking a couple of questions, but I want to encourage everyone to put their questions in the chat box. What I would conclude is that we've got two parallel processes obviously affecting each other. One is the spread of the infection, and two is the vaccination. And you're suggesting that we vaccinate individuals as quickly as possible to prevent the massive uptake of coronavirus. My view is that while that's true, the reality is it's not going to happen for another 6 months, exactly. 6 to 8 months, even under the best of circumstances. So I keep coming back to contact tracing and sequencing and isolation of cases, especially of cases that are in cases. What's your sense of that as control measures?
Well, they're really, we should be sequencing much more and surveilling much more. We should be doing contact tracing. We should be spending much more on this. It's a real national failure. That's better in England, but they're not certainly perfect in contact tracing. They're having their own surge. I think, so yeah, you're preaching to the converted, and you're right.
Yeah, no, I'm not.
You're right. You're absolutely right.
Suggesting you don't think differently, but and maybe Laura's better able to answer this question. Is there movement in the state of Colorado to get to a point where we're going to do more effective contact tracing and a quicker turnaround in terms of testing and maybe even just quick genotyping as opposed to sequencing?
Laura Bankers?
Yeah, right now we're doing really extensive contact tracing on any B117s we find. Outside of that, I don't know because I'm the bioinformatician. So I'm not I don't know that much about what we're doing there. And as far as sequencing, right now we're sequencing about 200 COVID genomes a week. And we're trying to ramp that up pretty quickly here. The US is only doing 0.3% of positive cases. And there's a big push for all the state public health labs to start ramping that up. So we're doing a lot. Utah is probably the best right now as far as the amount of sequencing they're doing, as well as Minnesota and Massachusetts.
Boy, I think if I were in charge of it, I would just create, a genotyping array platform and just screen for those variants in every single virus that you got.
Yes, so the problem, David, in the U.S. is vaccine is sort of like vaccines, but actually sequencing is kind of distributed in a sort of haphazard.
Yep.
This lab, that lab, all of the U.S. It's not an organized. What the British did was centralize it. They have this, I forget what it's called, consortium.
It's COG UK.
Yeah, that's it, COG UK, and we don't have that. We have this lab in Seattle and that lab in Michigan, and it's not enough. It would be good. It would be good to have that though. And so I think you're right about the vaccines. You can sort of think of it as two trains racing towards railroad crossing. And is the vaccine or the virus going to get there first? And is the vaccine going to be able to cut this off? And it's going to take really significant to get herd protection, herd immunity. It's going to take really significant vaccination rates.
Let's talk a little bit about mutation rate. So Sonia is asking whether, are you surprised about the mutation rate given the RNA polymerase proofreading abilities of the virus?
Yeah, so no, actually, because the overall mutation rate has not changed. The polymerase isn't speeding up or proofreading less. It's just that these variants, possibly by replicating without immune control for 150, 300, or 200 days in people who have no B cells, is accumulating more mutations. But the underlying mutation rate hasn't changed. So it's still a coronavirus, it still proofreads. And if those next string graphs show that the vast majority of it is just marching along as it always was.
And Mike Hollers asks, is a virus mutation in a pandemic essentially infinite, or do you hit a maximum rate?
Well, you'll chug along at a certain rate, except maybe in some patients, and the mutation accumulation is not infinite because there are all sorts of selective constraints. Most mutations cause a decrease in fitness. There's only so many ways you can make a functional spike protein that binds ACE2 and fuses. So the mutation repertoire is limited, but the more opportunities you give the virus over time in more people, part of the problem here is that the virus is so uncontrolled. But the rate is probably the rate in general is not really an issue. It's accumulation and niches the virus starts to explore. We now think that B117 made itself 30 to 50% more infectious per virion landing on a nasopharynx at a given point in time, and that's the problem there.
Mm-hmm. Now, Eric, I asked John Samet this question last week, and I'll tell you his answer. But basically, the question was, are these accelerated rates of transmission in Southern California or in different countries around the world, are they a function of the virus or the host? And John said that he thought that they were predominantly a function of the host. But it wasn't particularly satisfying to me because I given, first of all, the genetic variability is an issue as you're pointing out. But secondly, are there waves of viral infection? Does the virus go through phases of growth that affect transmissibility? It only seems like waves of transmissibility across the country, as opposed to different post-activity in terms of use of masks and social distancing, et cetera, et cetera. I don't think we're that much better in Colorado than folks are in Southern California, I guess is what I'm trying to say.
I mean, it's a good question. First of all, there's no reason to think that the hosts are biologically different. It again comes back to the exponential thing. Small changes mean a lot. Viruses replicate exponentially. If they type, you saw it, South Dakota went through the roof, it came down, California, everyone said, oh, we're good, right? And then now Southern California is terrible. So small changes in behavior, average across the population, restaurants, gathering, bars, not masking, all these things, super spreader events, because the virus doesn't spread evenly. It tends to spread from super spreaders. And so you have something like happened in the Capitol last week, or that picture of London. It's probably a small minority of people who are super spreading. So super spreader events can affect it, a lot of chance things. And small things can turn that exponential ratchet around and suddenly you're taking off. Look at Arizona. If you look at Arizona, it's kind of fascinating to me because it really was bad, and then it came way down, and now Arizona is. We went up in November, peaked around December 4th. They kept going, and they started a little later actually. So, again, all these things, it's like a forest fire with embers everywhere. You give it fuel, and it goes. The embers are here, there, everywhere. I think Colorado, I think it is behavior. I think Coloradans with polis being sensible. Unfortunately, you can't get politicians to do this for long. They don't want to do lockdowns, even though what I showed you is lockdowns may have helped the economy in the long run. But it just takes slippage for things to turn around. And now imagine that everywhere, no one changes. There's no rapid increase in vaccines. There's no changes in masks. There's no changes in restaurants. The bars stay shut or they don't stay shut. And then you add 50% greater infectious virion. It can just go through the roof. Yeah. And that's what seems to have happened there on Ireland. What seems to have happened in England, not proven, but it looks like that. And so the sort of high level people who do this for a living, the sort of phylogenomicists, epidemiologists, they are sounding the alarm. They are very worried about this. And they'll either be proven right or wrong or probably somewhere in between, but I'd be surprised if we don't. I mean, right now 72 cases of B117 have been documented with our crappy surveillance nationwide. And you could say, oh, well, don't get too excited. But there's no reason to believe the United States is different than England. So it's
Well, if we're
probably,
sequencing only 1% of the viruses, it's clear that that's a 1% assessment of the number of cases. So it's well over 7,000 cases in the US.
right. So yeah, it can turn on a dime. And I think my thought this morning when I saw my phone and looked at the latest numbers, yeah, they're right. And people have a reason to be distracted. I mean, good God, this week. But then when that couples with, cases are dropping in Colorado, well, in Utah, it's bad. In Arizona, it's bad. New Mexico went up and going down. There's this sort of chaotic going up and down around the country. And it's kind of like the forest fire gets some fuel and it takes off. And you tamp it down. So what's worrisome is if this is correct, you throw 50% more infectious or 30% more infectious into the mix in an exhausted population a year in, fed up, what will happen?
Right. So Katja asks a really important question, but brings up the whole issue of, clinical symptoms and clinical course. She brought it up in relation to the vaccine. Post-vaccine individuals get asymptomatic or mildly symptomatic infections. What's the chance of them getting severe infection? Is there any report at all that the genetic variants affect the clinical course of coronavirus that we've gotten used to?
Well, so right now there's no evidence that it affects the clinical course in more than wild type. I can show you some data that have come out. Let me just share my screen briefly again. So I was kind of waiting for this question, just why is this thing more transmissible? Is it the higher affinity for the ACE2 receptor that seems to pertain? Is there a higher viral load? Is there another thing? And I think it's complicated, but there is some preliminary data suggesting that higher nasopharyngeal viral load may also occur with B117. And this is a preprint, again, I've only chosen preprints that are from high quality labs, but they're still preprints. That might explain higher transmissibility. There's potential confounders here like timing, but as you know, if the cycle threshold is lower, that means the viral load is higher. And so with S gene target failure knockout, this is basically B117, you can see the average cycle threshold is lower than with wild type, and that's in 2 different gene targets and another one. So there is some evidence that you go down about 5 cycle thresholds in this thing. And now this is really complicated because several other reports are saying that nasopharyngeal viral load may be correlated with disease severity and mortality, which is a concept we're used to, of course, from HIV. The higher your load, the worse you do. Your set point. Different virus, different situation. But there's no evidence yet that, as I told you, that it's more pathogenic. It also has an OF8 deletion. Now that no one knows what that's doing, but in some sense, it's a kind of attenuated virus in that sense. Now, on the other hand, a very good lab, Akiko Isaki's lab, very good immunologist at Yale, she publishing like crazy on this. And she now has a paper, preprint, showing that saliva and nasopharyngeal viral load are different, and saliva viral load is associated with more severe disease. So if you look at the saliva viral load and mean spectrum of severity here on the y-axis, it's the higher the viral load, the greater your symptoms, including up to being deceased. The pink versus the blue here. So, but I don't want to spend too much time on that because I think that's a really confusing and contradicting mix at this point, the relationship of viral load to disease. And but I think right now, I think the way to look at this is the variants don't make you sicker, but they may transmit better.
It could, well, but what you're suggesting is it could make you symptomatic earlier in the course, which
Yes.
might reduce then the transmission because you're not walking around infected and asymptomatic, infecting other individuals.
Yeah, a lot of variables there, but
Too many variables.
yeah. I mean, I mean, what you're getting at is it's a very hard thing to nail down. But it would make sense if it's not, just because it binds tighter to the receptor doesn't mean that that's the reason for the increased transmissibility. I mean, binding tighter to the receptor could hurt entry. It all depends. And higher viral load, though, especially in the pre-symptomatic phase, could definitely lead, obviously, to more transmission. But then, if viral load is, we think, emerging, a few papers says it's correlated with disease severity, then why isn't this virus making you more sick? Possibly because it just peaks faster and higher, spreads better, but then it doesn't make you any sicker despite doing that.
I'm going to give Ed Janoff the last question here, but Ed, do you want to ask your question?
Sure. So I'm just thinking about whether we're actually seeing selection and immune resistance with SARS-CoV-2. We know that people with chronic infections like HIV show substantial mutation and resistance, and over time the antibodies become less effective. SARS-CoV-2 really a short-lived infection, but we do have a number of people we see who have prolonged shedding. So they get better, and for all the world, they're fine. Either they never were sick, or they got sick and they got better, but they shed for 30, 60 days. So if you were to sequence those later shed viruses, do you think they would show some sort of mutation and resistance?
Well, two things. First of all, determining whether it's just dead RNA being shed over time is complicated. People have talked about spliced versus non-spliced messages and so forth. But it's the one situation where you do get prolonged shedding is in immunocompromised. That's been documented in really multiple cases now. And there you have less immune pressure and you get more mutations accumulating
Right.
time.
But for the people who do have immune pressure, who are not severely immunocompromised, you'd wonder, are those viruses being selected and somewhat resistant, at least?
Well, certainly they must be, certainly on a population level, like what's going on in Brazil now, where a lot of people in Amazonia are seropositive. And if their antibodies wane, and some of them get reinfected, I think, these are effects that occur on a huge population level. It's not like in every person the virus is running around selecting and creating a new variant. These things tend to happen relatively slowly. It's kind of like an ocean liner cruising along, and then some variants emerge as it pushes through the whole population. But yeah, I mean, there's always immune selection.
Yeah.
And we know that from the seasonal coronas, right? They come back like a year or two later, and people that are again probably susceptible. So certainly immune selection on a population level, and perhaps, but again, most people think that V117 and V1351 and 11128 in Brazil didn't, maybe Brazil one, but most of them didn't select in a mostly immune population. They mostly expanded in a non-immune population. But You know, this is sort of hand waving because I think there's no definitive answer, but obviously, by definition, immune selection does occur over time.
Yeah. Okay. Thank you.
Eric, this was absolutely superb discussion. Thanks for leading it. Do you have any parting remarks that you'd like to make?
I think the parting remark I'd say is something that Eddie Holmes in Sydney, who's perhaps the world's foremost expert on viral evolution, has said recently, which is that it's really complicated, and immune selection on the virus will continue. It will be complicated, and the whole world, not just England, not just Ireland, not just Brazil, there's going to be ongoing complex selection pressure that's the outcome of many different factors. And so I would just resist, oh, it's this or that. It's probably many things. And these questions like whether he's immune selected or not isn't really clear, and they're not going to be. It'll be helped a lot by much better surveillance. I mean, unfortunately, the US is basically a big experiment. I mean, what people are saying is this country may be where we're going to see that South African variant and B117, again, we don't like to call these by countries, but we do, the UK variant, sort of compete with each other and see what happens. Whether we'll get the science to really document it population-wide with the amount, with the investment that we should be making isn't entirely clear.
Okay. Well, thanks again. It's great to have your expertise and to hear your thoughts. Appreciate it. We're getting together next week, and I'm pretty sure we're going to talk about vaccine distribution and
Important topic
across the state, and the policies and the changes that are upcoming. So make sure to join us next Thursday.
Sure.
Okay.
Thank you.
Bye.
Thanks for the great questions.